All right. If you saw the post I left on Classroom, I also gave a link to or a picture of the unit circle and all of its values. So you can actually kind of use that unit circle to kind of help you answer the questions that you're going to find in your next assignment. All right, like I said, I'll go easy on you on the first assignment. I want you guys to really like take this in and kind of like make sense out of it. Ask questions if you have them, and so on and so forth. This is new stuff, guys. It's tricky. So if you're having trouble with it, just holler. Let me know. All right. All right, so what are we going to cover in this video? Well, we covered the values in the first quadrant, right? We covered the values in the first quadrant for the unit circle, but what about the other quadrants? Like, how do we kind of like make sense of them, right? How do we get those values, right? Meaning like if I want, so we can do stuff like sine of, I can say sine of 60, and you should be able to look at the unit circle and tell me, oh, this is the y coordinate, right? At 60, and the value is root 3 over 2, right? So you should be able to tell me that. But what happens now when I have something like sine of 120? What does that mean, right? Well, good news is it still means the y coordinate. But now it's saying the y coordinate at 120 degrees, which is like somewhere about here. Okay, so I'll just let you guys know now. When you do these problems, you will always be able to find the exact values, because the way the problems are, they'll always give you like different versions of the angles that we covered in the first quadrant, right? So long as you know the values in the first quadrant, right? You should be good. You should be able to find all the other values in the other quadrants. So what does that mean? There are, if I do the math right, okay, there's 3 points per quadrant. There's gonna be 3 in this one, 3 in this one, and 3 in this one. You should be able to tell me, right? You should be able to tell me the 12 points here that are going to pop up. Technically, okay, plus 4, which is 16 because of these guys. So you should tell me, like, you should be able to find the 16 values, right, in the unit circle, just by knowing the first quadrant. Okay, and once again, like I said, you feel free to use the unit circle that I give you in the classroom to help you. I mainly want you guys to understand that sine represents y and cosine represents x. Okay, so let me kind of break it down for you. Let me just do a problem for you real quick and see how this goes. All right. So I don't know. Let's try cosine of 3 pi over 4. Oh, what the heck? That's a radian. Didn't expect that, did you? All right. So there's a couple ways you can do this. All right. You can turn the radians into degrees, or you can think about it, analytically, however you want to do it. I'll keep it easy for you guys, and I'll turn the radians into degrees for you, okay? Cosine of 3 pi over 4, it's actually the same thing as, if I do this right, 180 over pi, right? Because we learned that in the last section. Pi's cancel out. You're left with, it looks like 135 degrees. So we have to kind of visualize this, right? Cosine means what? Cosine means x. Oh, you can't see that, can you? X-axis. All right. So not x-axis. What am I talking about? X coordinate. Oops. All right. X coordinate. So cosine means the x coordinate. Okay. Now we got to think. Where is this bad boy? Where is this? Where's 135 degrees? All right. In the last section, we learned how to graph these, angles, right? And you know that this one's 180 degrees. You know that this is 90. So that means this is somewhere. In fact, this is going to be right in the middle of 90 and 180. And if you think about it even more, well, think about it. How far away is 135 from 180? How far away is 135 from 180? It's actually 45 degrees. And you should be like, oh snap, that looks familiar because we learned about the 45 degrees in the first quadrant, right? So what does this mean? I can look for the coordinate point in the first quadrant at 45 degrees. It was root 2 over 2 comma root 2 over 2. And since this is a circle, everything's symmetric. That's why mathematicians are so fascinated by circles, right? It's perfect in all of its ways, right? So it's really cool. So anyways, because of that, right? Essentially, what this means is this value should actually be the same thing except for the x coordinate because we are now in the second quadrant. I know it's a lot of stuff going on right now, right? Let me kind of recap here. We're looking for cosine of 135. Cosine means x coordinate. So we're looking at the x coordinate. 135 is in the second quadrant. We're no longer in the first quadrant. We're in the second quadrant, which means it's going to be negative root 2 over 2 comma root 2 over 2. Right? And that should make sense. The height didn't change, right? Y didn't change. But the x did. The x had to go left. It didn't go right. So that's why it's negative root 2 over 2. This guy right here. Right? So x coordinate, once again, that's that one. It's negative because we're in the second quadrant. And that's it. We just figured it out. The answer is negative root 2 over 2. If you don't believe me, check that unit circle on that in that picture I gave you. If you go to 135 degrees, the x coordinate is negative root 2 over 2. All right? I know that kind of seemed like a lot, all right? But this next one's going to be a little faster, all right? So you guys should get the hang of this a little bit better here. All right, so I'm going to give you guys, oh, I don't know. How about this? Let's go sine of 390 degrees. Oh no, what? He went past 360. No way. Yes, way, right? Sine of 390. Once again, break it down. Sine means what? What does sine mean? And notice, I'm like writing all this down. You know, you should be writing this kind of stuff down too, right? As you go along, until you get the hang of it, at least. Sine means y. Right? Y coordinate. 390, where's that? Well, that is, well, we know where 360 is, right? 360 is going all the way around once, right? And then 30 more degrees. So that means it's somewhere over here. And we're like, oh, look, that's 30 degrees. Well, we know that. We just found what that was in the first video, right? It's in the first quadrant. I don't need to worry about the sign change. I just look at the unit circle and I see it's root 3 over 2 comma 1/2. And what am I looking for again? Oh yeah, the y coordinate. And what's the y coordinate? It's 1/2. So the answer is just 1/2. Easy peasy. All right. I'll do one more just because I'm feeling it. Let's do, I don't know. Let's do cosine of 11 pi over 6. Cosine of 11 pi over 6. So once again, cosine means we're looking for the x coordinate. But now we got to think, what the heck is 11 pi over 6? So on the first one, I turned it into a degrees. On this one, I'm going to leave it radians. Because to me, radians is much easier to play with. Think about it. I have 11 pi's over 6. Well, what is that? That means this is going to be trying to think of a way to phrase the question here. I got to think how far away is this from from an even pi, like a nice pi number? Like, is this close to 1 pi? Is this close to 2 pi? Is this close to 3 pi? So on and so forth, right? Well, if I break this up, right, 6 goes into 11 once, so this is going to be 1 full pi plus 5 pi over 6, right? This is because this is 6 pi over 6 plus 5 pi over 6, and 6 plus 5 is 11. Hopefully that was clear enough. Right, so I have 1 full pi and then 5 pi over 6, which means I am pi over 6 away from 2 pi. All right, and if you've hung with me this far, what does that mean? This is pi, this is 2 pi, right? Pi is 180 degrees. 2 pi is 360 degrees. So this means I'm actually really close. I'm really close to 360 degrees. If you did not like any of that, I understand. I know you guys are still getting used to the radian stuff. Just turn it into degrees. 11 pi over 6 times 180 over pi. Pi's cancel out. You're left with, what is that, 30? Right? And this is 330 degrees. So what is this? Cosine of 330 degrees. And that matches up with our picture. This one is 30 degrees away from the x-axis. All right? So this one, it's going to kind of mirror the 30 degrees that we found in our first quadrant, right? And we said the 30 degrees was root 3 over 2, 1/2. So think about it. What's going to change? Is the x value going to change? Is the left-right distance going to change, or is the up-down distance going to change? Pause the video and think about it for a second. You got it? You sure? All right, it's going to be the y value that changes, right? The x value, right, the left to right distance didn't change at all. It still went to the right the same amount. It still went root 3 over 2 to the right. But instead of going up 1/2, it went down 1/2. However, does this matter for our problem? Does this matter for our problem? That the y changed? No, it doesn't, because the x, we only care about the x coordinate, right? So was that work for nothing? No, not at all. We still needed to know where the angle ended up, right? So we know our answer is going to be root 3 over 2, because that's the x coordinate at 330 degrees. All right, so hopefully you guys got a hang of this. Try the problems that are posted on Classroom, and yeah, let me know if you guys need anything. All right.